Welcome to my YouTube channel Mechanical Engineering Management, and this is the Machine Design lecture series. And today we are going to discuss about the design against fluctuating load, and specific topic is on endurance limit. So let's see first of all the question that can be asked in your examination. What is endurance limit? So let's see first of all the concept about the endurance limit. So here you can see endurance limit is also known as the fatigue limit. So let's see what is exactly the meaning of fatigue limit. So start with the definition. The endurance limit is the maximum stress level. Additionally, there are some of the important points. That maximum stress level a material can withstand. One more important point, for an infinite number of loading cycles. So here you can see these are the number of cycles for the failures without failing due to the fatigue. So this is very important point. Endurance limit is for the fatigue load only. So if there is a fatigue load, then and then maximum stress level is known as endurance limit. So very simple definition for the endurance limit. You can see the maximum stress level a material can withstand. This is the point number one. Second, for an infinite number of loading cycle. Third one, due to the fatigue without failing. Now let's see the key points. It applies to materials subjected to repeated or cyclic loading. So here you can see these are known as the repeated or cyclic loading. And specifically this type of the case is possible in rotating shaft, springs, etc. If the applied alternating stress is below the endurance limit, here you can see if the applied stress is below this endurance limit, the material will not fail due to the fatigue. Even after millions of cycles, here you can see the endurance limit is flat after this point. That means material will not fail below this stress level for the infinite cycles. Endurance limit is represented as SE or sigma E. Here you can see this S is represented for the stress and E is for the endurance. So this is the endurance stress level, or you can say endurance stress limit. And here also you can see E is represented for the endurance and sigma is for the stress. Now there are basically three key values to understand the endurance limit: plastic, elastic and infinite life region. In this figure you can understand from here to here, that means from ultimate stress to the yield strength, there is a plastic region. And from yield strength to endurance limit, that is called as elastic region. And after this endurance limit is called as the infinite number of cycles. So basically there are three regions to understand the endurance stress limit with respect to the number of cycles. Now what do you mean by ultimate stress? So again it is very simple. Stress level required to fail with one cycle. So if you want to understand for the one cycle only, then ultimate strength is in picture. Yield strength, dividing line between elastic region and plastic region. So this yield strength, that is actually bifurcate these two regions, plastic region and elastic region. And last one, endurance limit. If all cycles are below this stress level, then material will tolerate that stress limit. That means there will be no failure occurs. So you can say the endurance limit is the stress threshold, or you can say this is the value of the stress below which the material can tolerate, or you can say endure, for essential unlimited number of cycles. Here you can see there is a flat line. That means for the number of cycles, or you can say infinite number of cycles, the material can withstand or material can tolerate that stress limit without failure. Generally, the infinite number of cycle is commonly taken as 10 raised to 6 to 10 raised to 7 cycles without fatigue fracture. So if there is a fatigue load, then and then endurance limit will be in the picture. So can you tell me, my dear friends, what will be the unit of the endurance limit? Yes, it's very simple, because of you know that this endurance limit, that is actually the value of the stress. And you know that stress is the load upon area, and so that the unit of the stress is Newton per mm square or megapascal, and that same unit is for the endurance limit. Now typical values. Many ferrous materials, means like carbon, steel and iron, show a clear endurance limit. In this diagram you can see, this diagram is stress versus the number of cycles, on which you can see the steel having the specific endurance limit. Here you can see, after that the line will be the flat. That means there is a unique value, or you can say the particular value of endurance limit for the steel. But for the non-ferrous metals like aluminium, copper, magnesium, here you can see this red line is represented for the aluminium. That means non-ferrous materials. So for the non-ferrous metal, there is no any specific or unique value to represent the endurance limit. So specifically for the non-ferrous metal, there will be no distinct endurance limit. That means they fail eventually at any stress level if the number of cycle is large. Here you can see, if the number of cycle is large, then it will be near to this line. Now, a very important question, where it is used. So first one, design of rotating machine parts. Because of there is a rotating, then there will be the number of cycles. Springs, gears, aircraft, automotive parts, etc. Now let's take one example to understand exactly the endurance limit. If there is a steel shaft, this is category 1045, has an endurance limit of 320 megapascal. Here you can see on this stress versus number of cycle diagram, this is the line represented for 1045 steel, and here you can see this is the endurance limit. So this is approximately 320 megapascal. It means that if the shaft is subjected to cyclic stress, or you can say fatigue stress of 320 megapascal or less than this 320 megapascal, it will theoretically never fail for the number of cycles due to the fatigue load. So thanks my dear friends for watching this video.